Now we have some data from our CSV with sales and we want to start graphing it. So first of all, let's create a new branch. So same as before, we come here, git checkout, and we're gonna call this branch first graphs. Okay, and now we can start adding the graphing functionality. So what we want is, first of all, we decided to use one library for the graphs, and this library is called Plotly. So let's open the documentation for Plotly. And we can see here in the getting started, here it lists the library we need to use using pip. So let's start with that to get it out of the way. So as you know, we can just use a command like this and we just install it. It's called Plotly. And there it is installed. Okay. Yes, so it installed it. And now we can run the command. If you remember the freeze requirements, this will update the requirements file. And as we can see, now it includes Plotly. So with all of these, our requirements file is always up to date. Here we can do a git diff. And you will see that it added Plotly and a library called retrying that Plotly depends on. So with this done, let's just import Plotly. And we just want to paint to graph something to get the hang of how this library works. So let's just see the documentation. Let's say a bar chart to start. And we're just gonna use this example here and just use it to graph something and then we'll tweak it. So let's just add it here at the very end. The import we want at the top. And this example here. And if we run it, let's see. If we run it, it created this in a browser window. So let me move it up here. Just a second. Let's make it a bit smaller so you can see it. But basically, it created this nice graph, like the one in the demo. But it opened it in a browser. So this is not what we want. Let me just make it a bit smaller. Yeah, so you can see there, that's the graph that it created. But it created it in this server, which is good for testing, but what we want for our command is that it generates an image in the folder. So we'll work on how to do that. We want an image, not a server serving a website. So let's see if we can find in the documentation of Plotly something that allows us to save an image. So let's see here. Somewhere there should be an API reference. Here it is. And then if you see here, this looks promising. Interface for displaying, reading, and writing figures, which is what we want. And exactly here, if you see this right image, this seems to be what we want. So let's try to use this Plotly IO right image. Figure file, format. Okay, so let's try to use this. For this, instead of this figure show, we're gonna pass the figure to Plotly. And I would say we need to import, let's import right image, or let's just import Plotly. And we can use it like this. Yes. We could also, of course, import directly right image and let's just use right image like this. But for now, let's use the whole path. And probably we need to provide a file name. So here it is, file, string, or writable. So let's just pass a file. The format supported all of this. So it supports even vector graphics. So it's a bit surprising, so even better. But for now, let's try to save a PNG. So I would say probably we can just pass the file name with a PNG and it will pick it up. Figure file, yeah. So we can just pass the file here, and the file is going to be, let's say, output.png, and we're going to run this and see if it works. So let's see. Image generation requires the ps-util package. So let's go really quick and install the package. ps-util. It's installed. Let's freeze the requirements like every time we install some package. And now let's run it again. Also requires requests. Okay, let's do the same thing with the request package. The request library is used to do HTTP requests, so I'm not sure why it needs this, but let's go for it. Same thing with the freeze requirements, and let's try it again. Okay, and there seems to be some failures. Now it's saying Orca is required in order to export figures as static images. Okay, so we actually need to install like a binary. So we need this binary Orca. So first of all, let's see if we have it installed. And we already have it installed. If you don't have it installed, you could just add it here as an sudo apt-get Orca, apt-get install Orca. But since we have it installed, we're gonna do what the message is telling us. It says here we can configure like the path to the executable, which is this user bin Orca. So let's try that, and we just add it before the right image, and it's gonna be user bin Orca. So we put this here, and let's see if that works. Okay. So now let's run it again, and it still fails. So at this point, we can use the several libraries that that Plotly can use. I found this one called Kaleido. So basically, it can use either Orca or this Kaleido package. So let's try with this Kaleido package, because we don't really care which library is using underneath. We just want to save some images. So let's remove this thing with Orca, and let's install this Kaleido library. So we can use this to install it like before, and we install Kaleido. It's installing, finished, and then we freeze the requirements as always. So we can see here that it added all of these requirements. And let's try it. I think we don't need any other change here. It's gonna try to do an output.png. So we just type make run, and it seems to be finished correctly. We can see that it created an output.png. So let's see. And here it is, it created our image. So that's pretty good. Still, let's remember that this image we're seeing here, this is not our data, right? So this is coming from this px data gapminder, which is included in the library. So next we want to replace this graph test data from our real data, the one that is in this data frame. So let's see how to do that. We want to graph our data instead, so let's take a look. We can see here in this data Canada, it's loading some data, right? And this is the data that is being passed to the bar graph. So first of all, let's just print that data and see how it, if it's similar to the one we have in this data frame, right? So let's just run the program once more. Okay, and we can see this is our data, and here below is the data from this Canada census, maybe, probably. Yeah. So it's graphing this, for them it's graphing the year and the population. So we want to do something similar with hours. So first of all, hours is a bit different. We can see it has like columns that are empty. This is like not a number value. And then it also has like these headers, and it has these titles, sales per week from Glengarry, Glenrose. So we have to clean it up a bit so it looks a bit more like the other one. As we see in the other one, in the Canada, we're only using the year and the population. So the rest is completely accessory to this example. So let's start massaging the data for hours until it looks a bit better, a bit more like what this call expects. So first of all, I want to remove the not a number values. So to do this, Pandas has this formula, this function called drop NA, and this itself has many options, but basically I just want to drop all of them when all of them are not a number, then I drop them, and I'll do this just in place. So instead of having to do like data frame equals, I can just do this. So with this, we remove like all the not a numbers. So let's run it again. And now we see here, this column is gone, right? We still have some things here. So we want to remove these two columns because they're not part of the values themselves. So here we have the actual salesman, but this should be the title, right? It shouldn't be like part of the values themselves. So to do that, first of all, we want to load the CSV without a header. So there's this option. And if we run that again, we can see that now the header is not there anymore. So instead we get these numbers for the positions. And we still have these two lines that we don't want. They're not values really, they're more like descriptions we added on our spreadsheet. So, you know, if I open the spreadsheet, you can see this is more like for the readers of the spreadsheet, right? These are the values. So we want to reflect that here, and we can do that by removing the first two lines. So once we've removed the empty values, we can just remove with this function like the first two. So this would remove the first two. Basically, this copies everything after the first two in this data frame. So it will be the same effect as removing the first two. And if we print this again, we can see that now we have only the data, right? On the other side, we lost the names of the columns because we don't have a header, right? So we need to add this. So to do this, we can add basically Pandas as these df.columns, and we can just assign here the names. So if you look at our Excel file, the names are like salesman, week 1, week 2, 3, and 4. We're gonna use only week 1 for this example, but basically this could be any number of columns, same as here is like population or life expectancy or this other GDP per capita, etc. So salesman and the weeks. Let's see, so here at salesman, and then like week 1, week 2, week 3, and week 4. And if we print it now, we should see the nice header columns. And there they are. So these are the headers. As you see, they're not part of the, these are the values. Same as this other data frame. These are the header, this is the header, and this is the different values. So now it looks like we have it in a similar format. Let's try to graph something. So for instance, let's try to graph the first week, same as the example is graphing population. So for this, let's just copy this line. Instead of data Canada, we're going to use our data frame. And then instead of year, here, so instead of per year, we want to do it per salesman, right? So we have like Ricky Roma, Shelley, all the salesmen. So here we're just going to type salesman, and the value to be printed is going to be the value in week 1. So let's see if that works. we run it, and it did an error out at least. And if we look at it, this is the output. So it looks like it graphed everything correctly, but if we look at it, look at this, like Ricky Roma is the one that sold the most, right? He sold 20 the first week, the others sold less. But in this graph, it looks like he did very bad. There's something weird going on here. And what's happening here is that this value is a string. So somehow it's getting confused. It's not taking it as a number. So let's take a look. Again, I'm gonna make a copy of this to compare it later. So let's just say it is like before. And then what we want to do is to tell pandas that this we don't need. What we want to do is to tell pandas that this column, week 1, is not a string, is an integer. So to do this, we just type here as integer, and this is telling for pandas for this data frame week 1, this is a type of integer, right? So now when we graph it, we can see here, let's just leave it run. And now if we see the image, right, this makes sense. Like Ricky Roma is by far the best seller here, and the others are there. Shelly is doing very bad in the first week. And if we compare it to the graph before, here we can see, right, so the one on the left is incorrect because it was using it as string, and this one is actually using it as numbers, so this one is correct. We can of course graph this in a lot of different ways, but for now we're able to graph one column, the week 1, versus a list of things. Could be years, but in this case it's a salesman. So this is the one we want. We can delete the output before. And now let's commit these changes. Then, before we commit these changes, let's just delete all this old code that has been accumulating. So we don't need this example anymore with the Canada data, and we just leave it like this. So this is what's working, and then we just confirm it runs, and it runs correctly. And now we're just gonna commit these changes. So as we see, well, here many things. I have the spreadsheet open, so it's creating this temporary file. So I don't want to commit that, and so let me just close it, maybe it's easier. Okay, but also we don't want to commit the image files that were generated. So for that, let's just add something to our git ignore. So here we want to add also our output.png. Okay, so now we won't commit the images. Otherwise, every time we generate a new image, we'll be committing it to the repository. So other than this, we can do a git diff to see what we're going to commit. And everything seems about right. So git ignore some dependencies. If we are not sure if we have all the dependencies, we can just run freeze requirements anytime, and it should be updated now. So let's add all of these changes, and we can call this, we can commit this with a message, for instance, graphing the first image from our data. Okay, now we push this, origin, and this is called first graphs. It auto-completes here, if you press tab, it's useful. And it's pushing it. Perfect. And now we can go to master and merge it. So first graphs. There it is, and of course we can confirm if we do git log. Here is our commit.